Okay, so we have the distance of a car is given by the equation s of t is equal to 3t cubed minus 1/4 t squared plus 3t. Here our distance is measured in meters and our time is measured in seconds. So the first thing that we want to find is find the distance traveled after 3 seconds. So what we want to do, we just want to use this equation because we know that this equation represents the distance. So the first thing I'm going to do is plug in the 3. So s of 3 is equal to 3 cubed minus 1/4 3 squared plus 3 times 3. Okay, and now all I have to do is just plug it into my calculator. So I will be plugging it in to my calculator, not on the screen. So I'm gonna, if you ended up using your TI-36X Pro, you probably got 351/4, and if I put it in decimal form, this is going to be equal to 87.75. And then in this case, since it's distance, then we know that this is going to be meters. Okay, that's fast. Okay, in 3 seconds. Okay, so now what we want to do is find the velocity after 2 seconds. Okay, so now we do not longer want the distance, we now want the velocity. We know that the velocity, v of t, is just going to be the first derivative of the position. So we're going to take the derivative of our position function. So I'm going to use the power rule. This is going to be 9t to the power of 2 minus, the 2 is going to go forward, so I'm going to have 2/4 t, and then the other one's going to be plus 3. Okay, because this is basically a 1, bring it over, subtract by 1, then I'm going to have t to the 0, which gives me 0. I'm sorry, which gives me 1. Okay, so now all I'm going to do is now I'm going to plug in v of 2. So I'm going to have 9, 2 squared minus, this is just 1/2, times 2 plus 3. So now I'm going to put that into my calculator. 9 times 2 squared minus 1/2 times 2 plus 3. And what I'm going to get is 38. It's going to be 38 meters per second. Okay, because that's velocity. Okay, now for acceleration, we want to find the acceleration after 1 second. So all we got to do now for acceleration, acceleration will be purple. So a of t is just basically going to be the second derivative of the position function. But since I already know the first derivative, all I have to do is just take the derivative of my velocity function, okay, which is just this thing. Okay, so I'm going to bring this forward. I'm going to have 18 t, and then I'm going to bring this forward. I'm just going to get 2 to the 4th, which is going to be 1/2, so minus 1/2, and then the derivative of any constant is just going to be 0. So now what I'm going to do, I'm going to plug in, whoops, that's not right. I'm going to plug in, what did I want to find? Oh, 1 second. So a of 1 into my derivative. This is going to be 18 times 1 minus 1/2. This is going to give me 18 minus 1/2, which is going to give me 17.5 or 17.5. This is going to be meters per second squared. Okay? All right, and that's how you basically do these types of problems.